Hello, and in this video we will be looking at intensity and refractive index specifically for EDEXCEL. We'll take a look at specification point 70 and 71 in this video. So specification point 70 states that we need to be able to use the equation for the intensity of radiation, which is power per unit area. And specification point 71 states that we need to be able to know and understand that at the interface between medium 1 and medium 2, N1 is multiplied by sine theta 1, which equals N2 multiplied by sine theta 2, where the refractive index is N, which is the ratio of speed of light in the vacuum compared to the speed of light in a given material. So basically, intensity is classed as the rate of flow of energy per unit area at right angles to the direction of travel of the wave, which has the units watts per meter squared. Now, we also have to have a look at refraction, and refraction itself is the change in direction of a propagating wave, such as light or sound, in passing from one medium to another in which it has a different velocity. And we also have to have a look at interface. An interface itself is a surface forming a common boundary between two portions of matter or space. So let's suppose that we have two mediums, medium 1, which is going to be air in this case, and medium 2, which is going to be glass in this case. The boundary line that separates medium 1 from medium 2 is the horizontal black line going across. The index of refraction of medium 1 is given as N1, and the index of refraction of medium 2 is given as N2. Let's examine the following incident ray, which is given as theta 1. So when it hits the boundary, some of that ray will be reflected while the rest of it will be refracted, and by the law of reflection, the angle of reflection will be equal to the angle of incidence. And by definition, the angle of incidence is the angle the incident ray makes with respect to the normal line, which is perpendicular to the boundary line. Now, due to different refractive indexes, the light ray will refract, and the light ray can basically bend away from the normal line or towards the normal line. So if the light ray will bend towards the normal, it's going from a less optically dense to a more optically dense material, therefore it is slowing down. Whereas if the light ray would bend away from the normal line, it's going from a more optically dense to a less optically dense material, therefore it is speeding up. And theta 2 basically, which is the angle of refraction, by definition is the angle the refracted ray makes with respect to the normal line. We now need to look at Snell's law. Snell's law is the relation between the angle of incidence and the angle of refraction and the index of refraction of both mediums, and this is given by N1 multiplied by sine theta 1, which equals N2 multiplied by sine theta 2. So to conclude, if the refractive index of medium 1 is less than the refractive index of medium 2, then the angle of incidence is greater than the angle of refraction. However, if the light ray is travelling the other direction, where glass has the refractive index 1 and air has the refractive index 2, then N1 is greater than N2, therefore theta 1 is going to be less than theta 2. Thank you all for watching. I hope this video has been useful on intensity and refractive index and cleared any questions anyone's had. Thank you and goodbye.